Hello and welcome everyone. Today in the physics sadhana we are going to be discussing about the topic of physics, properties of matter. I have classified the properties of matter into two halves, one is solid, another one is fluid. Previously we have updated the video regarding the properties of solid. Now let us discuss about the topic properties of fluid. First of all, we will be discussing about ECET PYQs followed by some important expected questions for the next year ECET examination question. Okay. So my dear students, those who have not watched the video from the physics sadhana, properties of matter, first video, that is properties of solid, make sure you go and watch that video and continue to the properties of fluid. Okay. There is no connection in between solid to fluid. Directly also you can watch this video, you can understand because it is not related to the previous one. Already we have updated the thermodynamics video too. Around 10 videos we have updated the heat and thermodynamics chapter of physics. Definitely watch those videos in order to enhance your knowledge in the physics and easily you can appear for the ECET examination. Moving on to the question number 1. TS ECET 2020, the question appeared from the soap bubble. The soap bubble, that is a surface tension concept. We know the formula for the surface tension is force acting per unit length or energy acting per unit area. The formula for the surface tension is equals to energy acting per unit change in area. Okay. So, energy will be equal to surface tension into change in area. Change in area. So, energy is equals to, what is the surface tension value given here? Surface tension value is given as 3.06 into 10 to the power of minus 2. 3.06 into 10 to the power of minus 2 Newton per meter, followed by A1 minus A2. As these are bubbles, we need to take surface area. What is the surface area for a soap bubble? A bubble is going to be spherical in nature and inside we are having one surface, outside we are having one surface. So, surface area will be equal to inside surface area plus outside surface area. So, totally it will be written as 8 pi r square. So, 8 pi would be common here and inside I can write r1 square to r2 square ratio. Okay. So, you can write like this. So, change in the area when energy is going to be positive. So, larger value minus smaller value. So, I will be writing here r square minus r square. So, better we will write r2 square minus r1 square. So, let us make it this one as a2 minus a1 because area is increasing. Final radius is 4 centimeter, initial radius is 3 centimeter. So, that is why I want to get a positive value and we are writing here r2 square minus r1 square, that is 4 square 16 minus 3 square 9. And 16 minus 9 is going to become 7 and this pi value is 22 by 7. So, this 7 gets a cancel. So, let me write it here one more time. E is equals to 3.06 10 to the power of minus 2 into 8 22 by 7 into 7. 7 gets cancelled. Okay. So, 22 times of 8. Okay. 22 times of 8 is 8 2s are 16, 8 2s are 16, 17. So, this is 176. 176 times of 3. 176 times of 3, 3 6 are 18, 3 7 are 21, 22, 3 1 are 3, it says 5. So, around 539 exact value because 0.06 is also there here. So, 539 or 28 I can write here, 28 into 10 to the power of minus 2. You see the units here, centimeter is given. So, if it is a centimeter, so what we need to do? We need to write the 10 to the power of minus 2. 10 to the power of minus 2 whole square is going to become 10 to the power of minus 4. So, here we will be getting 10 to the power of minus 4. So, now the total answer is going to become 528 into 10 to the power of minus 6. Okay. Now, it is correct, that is in terms of joules. So, the correct answer here is 539.6 into 10 to the power of minus 6 joules. Okay. Go through it once. Next question now, the next question given over the board is, see here, read the following statement about the viscosity. Viscosity of the liquid increases with the temperature increases. Remember, the viscosity of liquid is having some inversely proportional to temperature relation. So, temperature increases, viscosity decreases, whereas in case of gases, it's directly proportional to temperature change. Temperature increases, viscosity of gases also increases. So, viscosity of liquids increases, this is a wrong statement here. Viscosity of gases increases with increase in the temperature. This is a correct statement. So which one is correct? Only B statement is going to become the correct answer. Go through it. Moving on to the next question. The next question given over the board is repeated asked question. This is a repeated question. You see TS ECET 2020 question. This is 2020. Viscosity of gases increases as temperature increases. This is 2021. 2021. Viscosity of gases increases with increase in temperature. Same question. Viscosity of gases increases when temperature increases. Directly proportional. Moving on to the next question. Question number 4. Question given is, which of the following statement is false? Viscosity is independent of surface area of the fluid layers. We have the formula that viscous force is equals to eta into A into velocity gradient V divided by X. So now we can say that surface area is there. So this is a false statement now, because it's saying that independent is saying. So that's why this one is what? False statement. Viscosity of fluid changes with temperature. Yes, we know that viscosity for the liquids is directly proportional to temperature change. Yes or no? So this is the correct statement. This one is true. The dimensions of viscosity is same as the product of pressure and time. Unit of pressure Pascal, unit of time second. What is the unit for viscosity? Viscosity unit is Pascal second. Pascal second. So yes, this statement is also what? True. The viscous force is directed opposite to that of the direction of motion. Yes, this is a plate now, which is placed over some lubricating oil. Suppose this is oil now. Okay. And now this body is going to be moving with velocity v. Okay. Then what is the resistance force will come into existence? The resistance force is called as which force now? Viscous force. So is the viscous force opposite force? Yes, this statement is also true. So what is the false statement now? Which one is the false statement? Option 1 is a false statement. Go through it. Moving on to the next question. If D is the density of the liquid rises to a height h in the capillary tube of density of radius r, this is direct formula for the surface tension in terms of capillarity. If there is a tube and having some fluid, this fluid is going to be maintaining its height due to surface tension. And let's say here the surface tension is equals to what? T at an angle of theta. So vertical upward force will become T cos theta for a circular length. What is the circular length? It is 2 pi r. So surface tension is T is equals to force divided by 2 pi r, where this T is actually not T, it is T cos theta. So what is the force going to become? Force is equals to T cos theta into 2 pi r. This is the upward force. This is the upward force. It is maintaining a particular height against the direction of gravity. So vertical downward force is what now? Weight. Weight formula mg, mass into gravity, density into volume into gravity, density into area into height into gravity. Density area formula pi r square h into g. In the question is mentioning density is what? D. So d pi r square h g is the formula for which force? Downward force. This is downward force and this one is upward force. Equalizing these two forces now, upward and downward, equilibrium condition. Upward force is equals to downward force. Then what happens? Formula is T cos theta into 2 pi r is equals to d pi r square h into g. Okay. So what gets cancelled now? Pi r gets cancelled. Now it is going to be the right hand side. Surface tension is equals to, I will be writing like this, h r dg, just interchanging the positions, h r dg divided by 2 cos theta. h r dg divided by 2 cos theta, which is given in the option number 2. Important question, have to memorize. h r dg divided by 2 cos theta, from which we can write that h r dg, where h and r, h is inversely proportional to r. H is inversely proportional to r. Go through it. Moving on to the next question. The next question appeared in the ECET 2022. An iron needle is going to be placed. over the surface of water floats. Over the surface of the water floats due to, because there is one upward acting force is there which is supporting this. There is upward acting one force is there. What is this force called as? Surface tension force. This force is called as a surface tension force. Surface tension force. Okay. So what is the correct answer for this question? Surface tension is the correct answer. Moving on to the next question. Along a streamline flow, that is one dimensional flow, fluids are flowing without change in their properties in that direction. Laminar, streamline flow. So at a particular point, at a particular position, velocity is a constant. Okay, given position, velocity is the same. Go through it. Next point. The next point is a metal plate of area is placed over force and viscosity equal. We know the formula F is equals to eta into A into V divided by X. F is given as 1 micronewton, micro is 10 to the power of minus 6, micro 10 to the power of minus 6 Newton. Okay. Eta is our question, viscosity, area is given as 10 square centimeter square, centimeter is 10 to the power of minus 2, 10 power minus 2, 10 power minus 2, 10 power minus 4 because centimeter square is there. So 10 to the power of minus 4 meter square it is now, area. Velocity is given as 1 centimeter per second, velocity is given as 1 centimeter per second, 1 centimeter per second divided by x, separated by the layers of what? 1 centimeter. So here centimeter gets cancelled. Okay. Now 10 to the power of minus 6, 10 to the power of minus 4, 10 power minus 4, 10 power minus 4, here 10 power minus 2. Okay, this 10 to the power of 2 is going to the left hand side, this will become also 10 power minus 2. 10 power minus 2, 10 power minus 2, 10 power minus 4. So this is going to become 10 power minus 4 Pascal second. This is your answer. 10 to the power of minus 4 Pascal second. Go through it. Moving on to the next question. The next question given over the board is: water rises to a height h, capillary tube, radius r, mass is m. Mass of the water changes to what value when the radius of the tube becomes half? Okay, if mass changes to m by 2, radius changes to r by 2, r1 is equals to r, r2 is equals to r by 2, m1 is equals to m, m2 is equals to 1. So he is asking the relation between radius and mass. We know the formula for the surface tension, T equal to hr dg divided by 2 cos theta, where d is water density. Density is equals to mass divided by volume. So I can write like this: R into mass by volume, mass divided by volume. Okay, R into m by v is equals to some constant. So R into m divided by volume. Volume formula is pi r square h. Pi r square h is equals to constant. Okay, I don't want the h, I don't want the pi. Okay, because these two are constant, r by r square. So what is it going to become now? Rm by r square is equals to constant. R gets cancelled. That means m by r is a constant. If m by r is constant, that means m is directly proportional to r. M is directly proportional to r. So m2 divided by m1 is equals to r2 divided by r1. That means m2 by m is equals to r2 is r by 2 divided by r. R gets cancelled. This is 1 by 2. I am going to the right hand side. M2 is equals to m by 2. That means if radius becomes half, mass also becomes half. So what is the final answer you are going to get? M by 2. Okay, go through it once. Have to understand. Moving on to the next question. The next question is ECET PYQ TS ECET 2024. This is the continuity equation. Continuity equation is mass flow rate remains constant. Mass flow rate will be remaining a constant. That is mass by time remaining constant. Mass formula is density into volume. Density into volume divided by time. Density here denoted with rho. Volume formula area into displacement divided by time. Displacement by time is called as velocity, rho AV. That means rho AV is a constant. If it is constant, we can write like this: rho 1 A1 V1 is equals to rho 2 A2 V2. So this equation is called as which equation? Continuity equation. Rho 1 A1 V1 is equals to rho 2 A2 V2. So the correct answer is option number 4. Go through it once. Let's move on to the next question now. The next question given over the board is important bit stuff. Expected question in the examination is the height of water in capillary tube. Height of water. What is the formula? Surface tension is equals to HRDG divided by 2 cos theta. Now what is the relation between H and R? Expected question in the examination. I have already given this relation when we are discussing about the derivation. What was the relation between the H and R? H and R relation inversely proportional. That means radius of the tube increases, then capillarity decreases. Radius of the tube increases and capillarity decreases. It is height and radius. Height and radius are inversely proportional to each other. Okay. Radius or diameter, whatever it is. Okay. The question is given as height of water in capillary tube increases with increase, increases with decrease, decreases with an increase in surface tension, increases with increase in specific weight. So this is the correct answer. Increases with decrease in diameter. If diameter, this is radius, radius double is diameter. Right? If radius is gonna be decreasing, then what happens to the height of the capillary tube water? Increases. Moving on to the next question. Iron needle placed on the water surface in the floats of the tank when its weight is, although its weight is moved. This is due to. This is already appeared a question in the PYQ. This is a PYQ question and again expected question in the examination. And expected to. So what is the correct answer for this one? Surface tension. Moving on to the next question. The intensity of the pressure developed by the surface tension of 0.075 kg per meter in a droplet of water. I have told you 3 formulas. One is droplet, another one is soap bubble or air bubble. This is jet. First formula was for jet, second was droplet, and third one was air bubble, and the last one is soap bubble. Then what are the formulas for change in pressure, change in pressure, change in pressure? The formula for 2T by D, this one was 4T by D, and this one is 8T by D. It is asking about droplet of water. Droplet of water or air bubble, for both the conditions the formula is 4 times of surface tension divided by diameter. Okay. So intensity of pressure is delta P. Delta P is equals to, formula is 4T divided by D, 4 into surface tension. What is the surface tension given in the question? 0.075 divided by diameter. Diameter is given in terms of mm and the answer that we require is in terms of centimeter. So here we can write 6 into 10 to the power of minus 3. This m is milli. In the milli we will be having 10 to the power of minus 3. We can write like this: 10 to the power of minus 1 into 10 to the power of minus 2. This 10 power minus 2 is called as centimeter. Okay, na? Centi. So the correct answer is going to become what now? Into 10 to the power of minus 1 centimeter. Okay. So 10 power minus 3, 10 to the power of minus 1, this is 10 to the power of minus 4. 10 power minus 4 goes here, it will become what? 10 to the power of plus 4. If you multiply the 10 to the power of 4 here, this is 1, 2, 3, 4. So it is going to become what? 750. 750. Okay. 1, 2, 3, 4. 750 into 4 divided by 6. Into 4 divided by 6. Or you can write this is centimeter square. Just give me a minute because this is Newton. This is also kg per meter, no? Kg per meter. So we will write like this first of all. Okay, just a second. It's correct, but I want to change the values separately. Let me write here: surface tension is equals to 0.075 kg per meter. 1 meter is equals to 10 square centimeter. So 0.075 kg divided by 10 square centimeter. Now it's correct. Okay. So here we will be writing 4 into 0.075 okay, kg divided by 10 square centimeter into diameter. Now the diameter is how much? Droplet of the water diameter is 6 into 10 to the power of minus 3. This is mm. I required centimeters, so 10 to the power of minus 1. Now it is going to become centimeter. So now we can say that these units are kg, centimeter, centimeter. This will become kg per centimeter square. Now it's absolutely correct. Okay. So how can we write this one as 10 to the power of 2? This is 10 to the power of minus 3, 10 power minus 1, 10 power minus 4. 10 square into 10 to the power of minus 4. It will become what? 10 to the power of minus 2. Now 10 power minus 2 goes to the numerator. It will become 10 square. So this will become 4 into 0.075 into 10 square divided by 6. Divided by 6. If I multiply now 10 square here, it will become what? 1, 2 zeros. So it's going to become 7.5. Or we can say that 0.75 is 3 by 4. So I can write like this: 4 into 0.75 into 10 divided by 6, where this 0.75 is 3 by 4, 4 gets a now cancel. Remaining is 3, 3 ones are 3 twos are 1 by 2, 1 by 2 is 0.5, 0.5 into 10, what is the answer? 5 kg per centimeter square. This should be your answer. Okay, maybe we missed something. Or options are not given correctly. Answer should be this one. Check the unit one more time. I guess the answer should be 5 kg per centimeter square. Okay, go through it once. 0.075 kg per meter it is. Kg per meter is given. Absolutely correct it is. Okay, maybe some difference is there in the question. Okay, maybe misprinted here, but the answer is absolutely okay. Okay, you check it once. Procedure is correct, formula is also correct, units are also correct. 4 into 0.075 kg per meter is given. Kg per meter, so we can convert that meter into centimeter. 1 meter is 10 square centimeter. This is correct. 6 into 10 to the power of minus 3, it is milli. So milli will become 10 power minus 1 centimeter. This is also correct. 10 power minus 3, 10 power minus 1, 10 power minus 4, 10 square, 10 power minus 4, 10 power minus 2, 10 power minus 2 goes to the top, it will become 10 square. 4 into 0.75 into 10, this is 3 by 4, 4 cancel, 3 ones are, 3 twos are, 1 by 2, 0.5, 0.5 into 10, that is 5. Right? Go through it. It is absolutely correct. Maybe units are something missing here. If kg per centimeter is given here, then what happens? This 10 square is not going to be there. Okay, then it would be 10 power minus 4. 10 power minus 4 goes to the top, it will become 10 to the power of plus 4. Then also answer would be different. It should be one more 0 here, one more 0. If one more 0 is there, then the answer will become 0.5. Okay, let it be. Let's move on to the next question. Coefficient of viscosity dimension wise, dimensions of dash. Dimensional formula is asking. Dimensional formula is very simple. We know the formula: F is equals to eta into A into V divided by Y, where force is F, eta into area, area is L square, velocity is L by T divided by some X or Y, distance it is, that is a L. So LL gets a cancel. So this is L square by T here. F is equals to eta L square divided by T. Send this to the left hand side. Ft divided by L square is the eta. So eta F L power minus 2 T. This should be your answer. F L power minus 2 T. Option number 1. Go through it. Next question is given over the board. Cavitation is caused by. Cavitation is formation of bubbles. Cavitation is bubble formation when Very important question and expected question in the examination. Remember this. When pressure falls below vapor pressure, when pressure falls below vapor pressure, this is very important question. That means it is due to which pressure? High pressure or low pressure? Low pressure. Falls means very low pressure. When temperature increases, bubble formation happens. Similarly, when pressure decreases also, bubble formation happens. Moving on to the next question. At a certain point in an oil, mass density is 959, shear stress is 0.216, velocity gradient is 0.21 second. Kinematic viscosity is, okay. First of all, let's write the formula for F. F is equals to eta into A into V divided by X. This V by X is called as what? A velocity gradient. Velocity gradient. A is going to the left hand side. This F by A. F by A is called as shear stress. Shear stress. So F by A is equals to eta A V divided by X. So this value is given. This value is also A is not going to be there. No? A is going on the left hand side. V divided by X. This is also given. So what is the F by A given as? F by A is given as shear stress is given as 0.216. So 0.216 is equals to viscosity into velocity gradient is given as 0.21 second. So this is 0.21. Eta is equals to 0.216 divided by 0.21. Ones are some ones are, okay. Remaining will be there. So 1 point something you will be getting. Definitely 1 point something you are going to get. Okay. Now he is saying that kinematic viscosity. This is dynamic viscosity. This is a dynamic viscosity. Dynamic viscosity. Now we require kinematic viscosity. Kinematic viscosity is dynamic viscosity by mass density. Mass density given as 959. So this is 1 point something divided by 959. So this 959 is approximately equal to, let's say it is 1000, okay, by 1000, that is 10 to the power of minus 3. 10 to the power of minus 3. Let me tell you the exact value here. Exact value. Easily we can find out that is 10 to the power of minus 3, but let me tell you the exact value for the confirmation. Okay. So the values are given as 0.216 divided by 0.21, that is 1.028, and this should be 1.028, and that divided by, okay, 1.028 divided by 959. 1.028 divided by 959, that is equals to 0.00107. 0.00107. Okay. The correct answer should be what? 10 power minus 3 only. 10 to the power of minus 3. This is going to become your correct answer. Okay. Moving on to the next question. The next question given over the board is shear stress is equals to mu into dV by dy are known as Newtonian fluids. Pick up the correct statement. The fluid which do not follow the linear relationship between the shear stress, shear strain, the substance which follow after yield strains are known as plastic, all of the above. Correct statement he is asking you to find out. The fluid which flows as shear stress is equals to this mu is none other than dynamic viscosity only, eta. So eta dV divided by dy are known as Newtonian fluid. Yes, definitely when it is proportional and directly proportional to each other, then the fluids are called as Newtonian fluid. So this one is absolutely correct. The fluid which do not follow the linear relationship between the shear stress and strain are known as non-Newtonian. Pick up the correct statement. Do not follow the linear relationship. Yes, this is also correct. Okay, no? Non-Newtonian. If follows, then it is Newtonian. If does not follow, it is non-Newtonian. The substance which flow after yield strain are known as plastic. Yes, this is also correct, because the material which is going to be behaving like this. Okay. The substance which flow after the yield strain, this is the yield strain, and afterwards this flow. This is the diagram for what? A plastic. This is the diagram for non-Newtonian. This is the diagram for Newtonian. This is shear stress, this is velocity gradient. Okay. So this is also correct. So finally, so answer is what? 4. All of the above. All of the above is the correct answer. Okay. Go for it. Moving on to the next question. The next question given over the board is fluid is a substance. Definition of fluid. Fluid is a substance which will deform continuously under the application of small tangential forces, small shear forces. Fluid is a substance which deforms continuously, indefinitely under the application of small shear forces, small tangential forces, small shear stress. So fluid is a substance which cannot be subjected to shear forces, always expands until it fill any container, has the same shear stress at a point regardless of its motion, cannot remain at rest under the action of any shear force. So most suitable answer is this one. Cannot remains at a rest under the action of any shear force, because it will deform it will move. Next one. Angle of contact in case of liquid depends upon nature of the liquid and solid, the material which exists above the free liquid of surface, both 1 and 2, any one of the above. Yes, it is depending upon the nature of the liquid and the nature of the solid, because adhesion, cohesion will come into existence. And based on the adhesion and cohesion, what comes into existence is surface tension. So angle of the contact is, yes, definitely depending upon the nature of the liquid and solid, and as well as the material which exists above the free liquid surface. We know the formula for the surface tension, T is equals to HRDG divided by 2 cos theta. 2 cos theta. So surface tension is depending upon what we can say, two substances. Okay, two substances. And this density is depending upon what? Material property. Material property, that is fluid material. Okay. So definitely this angle of contact, which is theta, is going to be depending upon both 1 and 2. Both 1 and 2 is the correct answer. Next question. With the dynamic viscosity is 2 millipascal second, kinematic viscosity. We know the formula for the kinematic viscosity is equals to dynamic viscosity divided by density. Dynamic viscosity is 2.0 into 10 to the power of minus 3 Pascal second, or we can write kg per meter second 2. Density is given as 800. You know, this is 2 ones are, this is 2 fours are, this is 400. 1 by 4th is 0.25. 10 square it is. 10 square going to the numerator, 10 power minus 2. So it is totally 10 to the power of minus 5 meter square per second. Whereas if I write here 2.5, then I need to multiply with one more 10 to the power of minus 1. Okay, this is 10 to the power of minus 5. So this 10 power minus 5, 10 power minus 1 is going to become as what? 10 to the power of minus 6. 10 to the power of minus 6 meter square per second. I want to write here centimeter square per second. Centimeter square. 1 meter square is equals to 2.5 into 10 to the power of minus 6 into 10 to the power of 4 centimeter square per second. Centimeter square per second is called as Stoke. 10 power minus 6, 10 power 4, 10 to the power of minus 2, 10 power minus 2 is called as centi. So remaining is what? 2.5. So final answer is what? 2.5 centi Stoke. 2.5 centi Stoke is going to become your correct answer. Go through it. Moving on to the next question. Surface tension in fluid at the interface is measured in. What is the formula for surface tension? Force by length. Force is in Newton or kilonewton. This is in meter. Kilonewton per meter. So this is the correct answer. Go through it. Moving on to the next question. At a certain point in the castor oil, the shear stress is equals to viscosity into velocity gradient. Velocity gradient. Shear stress is given as 0.316. Viscosity into velocity gradient is 0.316. Okay. So both gets cancelled. What is the viscosity value equals to? 1 Newton second per meter square. Check the units again. This is Newton per meter square. This one is second. So Newton second per meter square. Both gets cancelled. Easy question. Moving on to the next one. Okay, this is the final bit now. One important question too. Expected question. So with this we have completed the properties of matter, in which we have covered the solids and as well as fluid. In the fluid we have discussed about the properties such as surface tension, viscosity, capillarity, angle of contact, and we discussed about cavitation too, and problems regarding the viscosities and types of fluid. Most important and expected question in the examination are only 3 properties. One is surface tension, another one is capillarity, and the next one is viscosity. Okay, make sure you go through the units of viscosity, which is very important. Let me give you all the viscosity units at one place. 1 Pascal second is equals to 1 Newton second per meter square is equals to 1 kg per meter second is equals to 10 gram. Okay, 10 gram, because it is kilo is 10 cube, 10 cube divided by what? 10 square, 10 cube by 10 square 10. So 10 gram per centimeter second is equals to 10 dyne second per centimeter square, that is equals to 10 poise. Okay, that is equals to 1 poisjoule also you can say. Go through it, all the units at one place. Pascal second, Newton second per meter square, kg per meter second, poise, dyne second per centimeter square, gram per centimeter second or poisjoule. Okay. So with this we have completed the properties of matter, solids and as well as fluid. Make sure you go through both the videos, understand all the PYQs, and based on the PYQs try to focus on the important bits, and definitely you can perform well in your ECET examination. Make sure you subscribe the channel and press the bell icon to be notified for every update from the SAIMEDHA Hyderabad. I wish you all the best. With such beautiful free content will be coming back daily in the physics sadhana. Thank you much. Till then, keep learning with SAIMEDHA.in.